In step 1 of hypothesis testing, what we need to do is take a statement about the population and convert it into two competing hypotheses. One is called the null hypothesis. This is what we're going to assume to be true. It's going to typically be an old, traditionally held belief or a claimed value for the population. It's typically going to be about a proportion or mean, although there are other kinds of hypothesis tests. So the null hypothesis is H naught. That is going to be in the middle of the distribution. HA is going to be an alternative belief, which might be on the left side or below, on the right side or above, or could be either. So what we have is three types of hypothesis tests: left-tailed, right-tailed, and two-tailed. With the left-tailed test, we assume that the population is at a certain spot, and then we expect some variability due to sampling. So we think of this as kind of like a margin of error to the left and to the right. Because the alternative belief is to the left, we would need a sample significantly to the left to get rid of that assumed null hypothesis. So let's look at some examples and we'll come back to the picture. In the first example, we see clearly right away a less than 55% or less than sign 0.55 for P. So this is a claim, and it's going to be either the null or alternative hypothesis depending on how everything sets up. Now the way we always need to do this is make the null hypothesis an equal sign. So if your claim is about proportion, you still use a P, and then you put an equal sign there. And that's because we need to assume something to anchor down the middle of this distribution. Now the claim actually said less than 55%. So imagine if it was 55%, which is what we'll assume, then we would expect some variability due to sampling. We could go above 55% by a certain amount depending on the sample size. So this distance right here will be our most likely margin of error, and we will shoot for a targeted zone called the rejection region that is equal to alpha in area, which we call the level of significance. Typically this is about 5%. So what we're saying is the bottom 5% of results are going to be too extreme to be able to accept this H0. Well, we never really accept it, but we instead use language that flips things around a little bit. We either reject the null hypothesis or we fail to reject the null hypothesis. So we're going to look for a sample significantly to the left to reject the assumed value. So going back to the example, what we'll want for our alternative is just to keep that less than sign. And what we're saying is here we have two competing hypotheses. It either equals 55% or with a significantly lower sample, we'll reject that assumption and we'll support the idea that it's actually less than 55%. In the next example, we have a slightly more challenging problem, because in this problem, the stated value of the population parameter is at least 49%. So that's P is greater than or equal to 0.49. Now this one already has equals, so we can't use that as the alternative hypothesis like we did up here. Here, this one is going to become the null hypothesis. We cannot separate a greater than sign from an equal sign if they were attached to one another. So here we might list this as a greater than equal to, or we might just call it equals, because that's the part that we really need to use to pin down the middle of our distribution. So essentially what we're saying is, let's say it was equal to 49%, then we would have a margin of error around that 49% in the middle. If it was greater than 49%, we would still be in this region. We would just shift our confidence interval to the right. Now, because it's kind of a complicated either equals or greater, it would be really difficult to justify that. You might find a sample that's significantly higher, but in that case, we would just want to make it a right-tailed test and just say more than 49%. So keeping things as it is, all we can really do is find a sample significantly to the left, and then we'll reject the null hypothesis. So if we get a sample that's significantly below or left of 49%, then we'll say we have some evidence to reject this claim that it's at least 49%. So something to remember in general is we can find evidence to support an alternative hypothesis, but we cannot find evidence to support a null hypothesis because that equal sign is going to mean that there will be some variability above and below that value no matter what. In the last problem, this is a longer kind of word problem. You really have to read through the whole thing and find the student's claim. So we have a student believes that the mean time is less than the traditionally held belief. In this case, that is an average of 6 years. So the student believes that the average is less than 6. That does not have an equal sign, so that will be our alternative hypothesis. H1, mu is less than 6, and the null hypothesis will need to put an equal sign there. That will be equals 6. Now let's look at a right-tailed test. This one is just like before, only we flip everything around to the right side. So I think we can go through this one a little bit quicker. In each problem, start by setting up your null and alternative hypotheses. You'll notice that I use a colon, not an equal sign, and that's because this is not an equation, it's just a label. And in each of these, identify the variable you're looking at. So this is more than 75%, that'll be a P. This one is at most or less than or equal to 53%. That'll also be P. And the last one talks about the average. The student believes that it's higher than 25,235. Next, determine where this should go. Is this going to be the alternative or the null hypothesis? If it doesn't have an equal sign, it's the alternative. If it does have an equal sign, it's the null. So we have greater than 0.75. For this one, we have less than or equal to 0.53. And in this one, we have mu greater than 25,235. Now in each problem, use the same symbol and use an equal sign. 0.75. This one's already got the equal sign, so I need the complement. I need to flip it around. And that's just because I can't use that same symbol in both. So if we look back, what we have is opposite facing symbols. We're going to always do that when we start with an at least or at most statement. And lastly, an equal sign. So now all of the null hypotheses have some form of an equal sign, and all of the alternatives are pointing to the right. Lastly, we have a two-tailed test. In this situation, we might have a claim that says a population parameter is a certain amount, like the average age is 25. Here we're going to expect some variation above and below it, and the only thing we could do is find evidence against the claim if we're too far above or too far below. The other way that this could be worded is you might have a claim that a parameter is not a certain amount, like the average age is not 25. Then if we're significantly far above or below that, we would have some evidence to support that claim. So in the first one here, we have 81% of car crashes. That's P equals 0.81. Because that has an equal sign, that's going to be my null hypothesis. Because I don't have any direction at all to go by, all I can do is use a not equal sign. That's what we have for a two-tailed test. Down here, we say we have an average duration here of 30 minutes. They take a sample, and then we have testing the average commute time of the elementary school is different than the commonly cited average. So here what we're actually looking at for our claim is not about P, but about mu, and mu is not equal to 30. So that one has a not equal sign. We cannot use that for the null hypothesis. We'll have to use that for the alternative. That's a two-tailed test because it has two directions where we could be, and then we change that to an equal sign for the null hypothesis.